Okay, we're up. So, Ben, you wanted to use this call to talk about aspects of the chain, particularly dustless operation. Is that correct?
Yeah. So, I mean, like full disclosure, I'm basically like a DeFi noob. Like I have done very, very little in this space. Um,
So has everybody else, let me assure you.
yeah. So Dust, as far as I read in the last week or so, is like leftover amounts of currency in wallets or at
You,
addresses where there's
yeah,
not enough.
you can simplify dust down to being an amount of stored value in a blockchain that is less than the transactional cost of moving it, and so it just sits there. And
Right.
that number, it doesn't like, it's also, that's the hard, like, mathematical based definition. Practically speaking, dust is bigger than the transactional value because, if you're going to lose 20% of your value, you're probably not going to transfer it either. As the transaction fees of a scarcity based chain go up and down with trending demand, your wallet goes in and out of dust state. So it's all sorts of things in practice, but the simplest way to define it is it's like your chain is incapable of sending value less than its transaction amount, and a dustless chain is one that can send value less than what the transaction costs are.
Right. So um, it's like the noise floor of the chain almost, right?
Yep.
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 Okay. That makes sense.
It's your precision that you can measure the chain at, pretty much.
Yeah. So I want to start by just kind of probing something that I've been thinking about, which is like, is it actually necessary for like tokens to be movable in this system? Like for you to be able to buy and sell tokens from one chain to another, from one address to another on a chain. Like to me, it seems like most of the things that you've proposed about how the system works could operate solely off of um, dividends and not equity grants.
Can you give me just 1 second? Somehow I lost the ability to show your pretty face on the stream. It's just an audio stream.
Really?
Yeah, that's not what I was going for at all. Oh, because got it. Okay, got it fixed. So it turns out the problem is that when I switch channels, the window title changes in Discord and did not get detected by OBS the same way. Anyway, my apologies, we're good to go. I see you've shaved 20 years off your life. What? Can you ask the question again?
Yeah. So it seemed to me as I was thinking about it that if what you're really trying to do is like just get people paid based on what consumers who are buying the software want, that you can do that with dividends and not move any tokens around. And then you can completely avoid the problem of um, pump and dumps, which require you to be able to buy and sell equity.
Yeah, so that's one of the design goals of the Dreamcatcher is to support a model where you only get paid as a royalty I mean, I think that's what you mean when you say dividend, but it's basically you only get paid when revenue occurs. You don't get paid really for speculation. And now the models that we're developing allow you to run a project in that way. We necessarily need to be able to model any conventional project so that we can model the world that we find ourselves in and program in reactions and appraisals based on that. But for the core Dreamcatcher projects, or the projects that are critical to function pieces of the Dreamcatcher, their mechanisms cannot have equity-based distributions. The notion of traces, which is basically an encapsulation of contributions made, those may still be subject to speculative booms and busts as people gamble over their long-term value as the royalties get paid to the traces. So there's still an element of speculation there, but each one is unique. It's not fungible. It's one-off. So it's not so decoupled from reality as a token, which is an arbitrary mechanism completely unconnected really to a thing.
Right. And how it relates to dust is like, if you don't need to pay people in currency and tokens, if you don't need to pay for transactions in tokens, then there is no dust.
That there will always be dust in that model. So long as your chain cannot pay by query, there will always be dust. And pay by query means that we define the minimum energy required for a transaction as a joule, which is it's a fairly arbitrary, but it's like, this is a standard transaction, this is what it costs. Over time, the next 100 years, the price of that will go down. It is impossible for it to take zero energy. So it's impossible that it ever be free. But
okay, let me back up again. What if the energy that it took was paid for in real currency?
That's the idea of the public chain, but it's still going to be a non-zero amount, which, based on the dust definition from before, means that there'll always be the ability for dust if you don't have a dust-free design. So why don't I jump ahead and try and describe how dust-free operations work, and then maybe that can refine the next round of questioning. The way that the design I've made for a dustless operation is based upon the seemingly natural discrepancy between the cost of read and the cost of write. The cost of read, particularly in blockchains, seems almost vanishingly small in comparison to the cost of write. And so if you allow payment by query, so if I say I've got a bunch of wallets, I've moved all those wallets to be under one parent. They all have an amount of currency in them that is smaller than the transactional cost of the chain, whatever that may be. Pay by query means that I can say something like, take every chain that's a child of this chain, take all the money down to zero, send it to this single address. And so it doesn't need to write to any of those child wallets. It only needs to write the query it performed and the resulting amount. And for it to be validated, all the validators that accept that, all they have to do to verify it is to read all those wallets and be like, yep, that's fine. It's writing that's expensive. It's technically the dust threshold, the dust floor is set by the cost to write. But if you allow that write to include a query of arbitrary complexity, then you can push the dust floor down by 1,000x type of thing.
Can I just jump in real quick? That in my dealing with Ethereum and Binance Smart Chain and whatnot, I find dust being a problem in terms of decimal places mostly, and how people define their decimal places and their precision of their contracts. So if I'm listening to you and Tom at the same time, I'm thinking that if we didn't have decimal places involved in transactions, then you've already solved a big problem with dust. I mean, so if 1 unit was 1 unit and it can only be higher than 1, it can never be lower than 1, then you're already creating a dustless system where transactions are always going to be base unit 1 and up.
Yeah, that's not really that doesn't fix we actually want the ability to do. We want to be able to effectively do payments that are smaller than the dust threshold in our chain, no matter how low that gets. And the reason is that, for example, if you look at an NPM package like LeftPad, I think it had like 30 million downloads last week or something. It's a very simple package. All it does is it pads a string out to the left by the number of characters that you said. It does it faster than you would do it naively. You know, someone else stressed about how to optimize that. That's fine. You can't really charge $1 every time it gets run, right? But our system needs to be able to attribute very tiny amounts to that package every time we use it and run it. And those amounts are going to be millions of times below the transaction threshold of our chain. And so what we need to be able to do is to allow the author of that package to hoover up all of the attribution payments that were made to him from a wide range of sources, and with enough of a transaction, so the transaction fee for him to claim that needs to be so low that it's feasible for him to hoover up all the dust every week or so, mint it into a new payment, and off he goes. So dustless operation is not about making dust impossible. It's about being able to meaningfully operate and account for value amounts millions of times smaller than the transaction floor.
Right.
And in our system, I mean, we want genuine, true attribution. I don't know how to prove it, but I would hope that the transaction costs for doing attribution in that way are so low that, we want that cost to be lower than the lowest possible unit of attribution that's meaningful to be paid. It ought to be so small. The payment that is no longer worth doing on our system should be so small that no one, you can't really do it.
Right.
Just the act of trying to pay that thing the smallest amount is sort of generating it's generating an event that means that you're going to attribute some more. It's the dustless operation is about just making it so low to send such tiny payments and allow you to bundle them up and re-amalgamate them, hoover them up into single packets. That's what I'm going for.
Right.
I think we're probably talking two different things here, but I know what you're talking about. I'm talking about I'm not talking about the actual physical payment in dollars or crypto or whatever the end payment is, whatever that attribute. If they hoover it up and it ends up being $100,000 worth of crypto or 10 cans, I don't care. I'm talking about how the system in the back end is actually calculating all this stuff as what 1 unit is. You know what I mean? Like you said, if you get down to 1 and you're doing operations at the single unit level, then the system just goes, there's no reason to be doing this anymore.
No,
and whatever 1 is.
No, we're aiming for unlimited decimal precision.
Right.
Unlimited.
unlimited decimal precision in the joule unit that you're referring to, or unlimited decimal precision of the payment system
of the value that you want to transfer. So the unit of a joule is going to fluctuate based on market forces. The cost in, say, US dollars or index dollars, whatever you choose, of a joule ought to be extraordinarily stable throughout time, and that's what I hope we leverage our currency against.
Right. Okay.
Ultimately.
Okay. We're kind of saying the same thing. What I'm saying is that if let's just say that 1 joule is our unit of work in the system, and 1 joule when we start up equals one nanodollar. Yeah. Right.
Yeah.
So that's what I meant by 1. So 1 joule would be 1 nanodollar, and nobody
I know
would.
What you mean, and I'm saying that my design goals are at odds with that. I intend to go beyond that. I intend for you to be able to feasibly transfer an amount of value that is much less than 1 joule, like millionths of a joule. But
let me go ahead. Sorry.
I was gonna make a conclusion that kind of lost its punch when I got cut off. That's cool. But I said what I needed to say. I guess the last few words would have added nothing.
So if I'm reading this right, we want unlimited precision in both directions, both in the actual measurement on the back end, and also in the real world whenever this gets cashed out into whatever this chip is.
That's true, but that's not my point with dustless operation. My point is that the joule represents the minimum amount of the minimum energy of a single transaction, and by design we can allow transfer of value that is less than that to still be economically viable.
Yeah, sorry. So that's what I'm sorry that I interrupted. What I was going to say is, it sounds to me like you are saying that it is possible to design the system in a way that even if it costs 1 million times more to move this amount of value around, like it's still economically viable to do that.
Yeah, because all you need to do is have 10 billion times of that 1 millionth of a joule, and then be able to bundle that up using, like, you know, it won't be 1 joule to do the bundling, but it might be like 100 joules or something. But because of the way that you can bundle queries as opposed to fixed amounts, you can amalgamate things and say all the dust that meets this pattern, call it 1, move it. If you can do that, you are dust free.
It's a deferred execution scheme.
Very much so, and that's, it needs to be deeply tied up to how attribution dispersal works, where, like, when you do the dispersal, you don't necessarily do it to everyone, because that's write access to all those chains. You do it, and then you sort of halt, where, like, the person down the stream who wants to cash it out needs to move the cascade on to pull out their attribution. Otherwise, it's uneconomical to do these extraordinarily deep attribution trees. Like, you'll eat it all in transaction costs.
So if I'm understanding you, then we're talking about an attribution algorithm that hits a critical mass. Once it hits critical mass, it batches these attributions and then pushes it back up the chain to the next node, if you will, or whoever that attribution goes to next.
Yeah.
And then they would sit on it, right? And it hits critical mass for them. Then the gate would go open, and it would open up to the next person, and it keeps going down, up and up and up the chain until it gets to the root, right?
And it's up to whoever controls that node that's accumulating to choose when to flip the gate when it makes economic sense for them. Who's to say what that value is? Only they can. They may just want to leave it sit. They're cool.
Right. So
what does that do? What does that do to people downstream, though, that are waiting on those?
People downstream are able to trigger that gate anytime they want, but they have to pay the transaction cost.
Got it. Okay. So in my head, I'm seeing competing competition interests. Some people want to get paid on Saturday. Some people want to get paid on Monday. But if someone on Monday is willing to pay the extra gas, they'll get paid sooner, and that'll push through the Sunday's payment as well, right?
Yeah, it makes it easier for people up the chain who didn't do anything. They sort of get some gas fees for free.
Well, yeah, because I mean, some people will be economic insensitive. If somebody who's much richer on the chain, let's say, has a few $100,000, and they see like there's $100 in dust sitting there, they might just say, "Well, okay, I'll just pay the $100 and get the dust out of there," and that frees up gas for half a dozen other people who are probably waiting because they're more sensitive to the economy, right?
Yep. All those kinds of things. Right. Yeah. But it's their choice, I guess, is my point.
Right.
And the whole the sort of the design principles of the chain need to allow this deferred dispersal. Otherwise, it's just so this is a feature that you can't do on Ethereum because of the gas fees. Like you need to. You can sort of, but not really. You're right. I mean, you can't in principle, but you can in theory at the moment. So it's just that nobody's really doing it yet. The EIPs are there, but no one's come up with it. That's another conversation we can have later on. That's outside this stream, but all right.
So
it's I guess the theme I keep hitting on is like I want the interblock blockchain deeply coupled with the Dreamcatcher, so that it's basically the currency of the Dreamcatcher. Not because we chose to make it that way, but because the features that it has are necessary for the Dreamcatcher's fully fledged operation, such as this ambient attribution, where no attribution amount is too small.
Yep. That would be a killer app, as they say.
Well, I think it's great because number one, it's how we should be doing things. Like I haven't paid a dime to Linus Torvalds, but I should. And it also has network effects, so it starts to actually build up money for people who aren't even part of the Dreamcatcher system, but who earnest and honest operators within the Dreamcatcher have been paying attribution to, even though they didn't have to, and it sort of draws more people in that way. And at the very least, it helps us build a data set that models, the provenance of things of value.
Right.
Correct. I agree with that.
It just seems like above all else, it seems like the right thing to do. It's also
it's an extremely important airdrop, if you put it for another way to term.
Right. And
like these are well-deserved airdrops too. It's not just we're not just airdropping to the guy, the team lead at Ethereum because we want notoriety or marketing or whatnot. We're doing it because this guy came out with a really great protocol, and and we're using it in his system. So therefore,
we
they get attribution.
Owe him, and everyone else does too, by the way. But we notice that not many other people are paying. So, I guess in a sense, what I want is instead of everyone trying to make open source business models where they're all different, and tokens are just another form of people trying to make open source business models, I think that there should really, not that I'm ever going to say that there should be only one business model, but I want to supply an option that allows there to be a shared single business model where everyone who has the open source business model problem can come and support each other by paying for each other's work, and then sort of only accepting purchases or demanding that their suppliers be following this fairness principle too, because you can't mix closed source and open source business models without killing something. Like they don't really work, but I don't want to have to make a new business model every time I have like an open source idea. I want the utility of the software to be the business model. Like my goal is to make it the best thing at what it does, not the best thing at what it does, and it has this weird distortion that makes you pay somehow. Like, that's annoying.
Well, I mean, in my mind, tokens, full stop, have been a complete failure. But that's another philosophical conversation. But I think the fact that we have to have tokens is a sign that it's basically we're still stuck at this old system. And
we just tried to blockchain the old system, and obviously it's having the same problems. But
I mean, if you think about it, Bitcoin, Ethereum, what was the real key technical value there? It wasn't the Bitcoin itself. It wasn't Ethereum. It was the fact that Bitcoin was this distributed ledger, right? There's this new technology that allows you to own things in the digital space. Yep. Ethereum came along and said, well, we can do more. Not only can you own things in the digital space, but we'll make it a computer. You know what I mean? And so that's what they did. So I mean,
a microprocessor. Huh? We're making a microprocessor from the 90s. I wouldn't call it a computer.
No, it's not even the 90s. It's worse than that, dude. We're talking like late 80s, man. We're talking ladder logic. I mean, I looked at when I started doing coding, and they were like, "Oh, these are the opcodes and this and that." And they go, "It's a stack." I'm like, "No, it's not a stack. That is ladder logic, bro. Don't rename it."
That's a great quote. You should get it on a t-shirt. They're like, that's ladder logic, bro.
Yeah. That's not a stack. Don't give me that. Anyways.
Me. So I mean, like, the design of the blockchain is meant to be that you can actually do it for large volumes of concurrent calculation, and it's economical to do so. Like, it should be cheaper for you to purchase computing resources from our mainnet than it is to buy it from Amazon directly. And then if you also consider the fact that the programming interface ought to be vastly simpler than using, say, Amazon Lambda plus DynamoDB plus CloudFront plus blah plus until your fucking eyes fall out. And then, right, and then you sort of want to then, at that point, you want to be able to present a labor marketplace that says, okay, I've heard this thing's cool. I can see people performing well with it. I want some code written. And we're like, here is a unified marketplace of everyone who knows how to do this. And here's their reputation. Here's their other stuff. Now, that's really what we're going for with the Dreamcatcher. Okay, so we got a blockchain. Whoop-de-doo. Okay, so the blockchain, I mean, even bad blockchains make tens of millions of dollars, right? Like, even shitty ones do. Even blockchains that don't exist make millions of dollars. But we're like, here's this blockchain, and we actually want it to be for real and to be sustainable and to be permanent. And that means making a mechanism to put a damper on the greed that kills pretty much every other project, which is like, it's attribution not just to you, but it's attribution to everything in history that came before you that allows you to be sitting where you are.
Right. That's
Does any of this answer your question, by the way?
Yeah. No, I mean, I think
okay, good.
Like Dust might actually be the wrong way to introduce. I know you have to try and fit like ideas inside of the prior art a little bit, but like to me, I think the thing that I missed when I heard the word Dust that you've convinced me of since you've explained it is that like you have to be able to capture values that are smaller than the amount of computer power that it takes to capture those values.
Yes. Yeah.
Because if you can't do that, then like you have some kind of minimum.
You truncate the attribution tree.
Right. You have some minimum amount of value that you're allowed to actually discuss on the system. And and that's going to necessarily leave out, like, you're just not going to, yeah, exactly. The attribution tree gets truncated. Yeah. You're not going to be able to look and see, like, all of the minor thoughts that went into the leaves, basically.
Yeah.
Oh, it's not just that, though, but it's also the storage space on the chain that gets eaten up for no reason because this stuff is just sitting there and literally collecting dust. Like literally just sitting there doing nothing.
Yeah.
So you obviously have a design in mind for it. Like, how does it work mechanically? Like,
a simple way to describe it is that let's say we have a customer relationship management system.
Mm-hmm.
My favorite example. And it's got 10,000 customers in it. In our prior design that we'd been working on together, you and I, we even to query one of those customer records cost you at least 3 blocks, right? 1 block to ask, 1 block to receive the question and reply, and then a 3rd block to process the response.
Is that 3 blocks? 3 blocks across two chains at least?
Yeah. Oh. So like ask the question, receive and respond, and then receive the response.
Right.
Now, a breakthrough for how that works, because that was painful. Like when you get to big queries, it starts to get like, oh my god. So I inserted the same way that I inserted async await into the reducers, I allowed for the insertion of async await queries that you can provide. And look, at the moment, the queries are blunt, like give me all the blocks, give me all the children of this chain, whatever. I would imagine that these queries, we can actually take the MongoDB language, query language, and just implement it verbatim into the system, because if you look at a tree of chains, they actually look like a large JSON object with reasonable structure. And so remember how we spent so long dealing with like, how do we deal with a big JSON object, like a 2 gig JSON object? I think that in reality, the answer is you don't, because who the fuck in programming land has a 2 gig object that they want to work with? Like no one. What are you doing? Why do you have that? You did that on purpose, almost. I
think that's ignoring the use case of like data lakes or whatever the fuck they're called.
Right, but even a data lake is a large number of recurring patterns. It's not like a big object that is completely irreducible or has no pattern. Like that's not, no one makes data.
I agree with you 100%. There is no such thing as a 2 gigabyte object that that has no internal structure.
Exactly, right? No one makes data like that. And if you are, it's probably binary. Like, we have a layer for that. That's not your semantic layer. That's your fucking raw data layer. So, so the answer to the big object problem, which I think we first started trying to solve in 2017, is don't solve it. Actually, each chain looks like an object. Each child has an alias for that object. Effectively, you can make an arbitrarily sized object out of chains, and if you just look at the state, it looks like one big object. If you just look at the state, it looks like a MongoDB database. Therefore, you can query it, and those queries are not writes, they're reads, and reads are fast, cacheable, optimizable, very cheap to do. And so in the CRM system, to be able to read from, say I want to search all customers for everyone named Bob, that's merely a query that goes out, and then it reads all those chains and gives me back the result. Same with Dust, and same with the mechanism for, because sometimes these queries are so big that you want to do them off computer or off the terminal. So you'd like, I am making my query, I make my query as a chain. I connect that chain to the wider provider or answerer of queries. They can work on it, and then ultimately the result comes back into the chain and I simply read the chain. Same sort of a deal with like a dust, let's call it a dust compaction activity is simply a query That's all.
Does it not like necessarily require some kind of write event as well?
It only requires a write event of the result of the query.
Right.
Which can be as simple as the sum of all dust equals this. So it can be very small.
Wouldn't you need to address all of the chains that are like carrying the dust though?
No, they can be addressed by pattern or by alias or by some other formula such as date, time, age, owner.
Chain ID,
Well, chain ID has that same problem. You can't address them all by chain ID. You can, however, address them all by owner or the public key of the owner, and you can roll them up like that.
Does this scheme only work, like both the queries and the dustless like compaction process that you're describing, seems like it would only work for things that are in a common hierarchy?
I think that the query necessarily has to be in a common hierarchy. I still don't have an answer for your question previously, like if you want to do that across multiple trees. Mm-hmm. The reason is that the query relies upon that root, the hash of the root tree, so that you can get a reproducible result every time you run it, regardless of what version of the tree you're looking at. So long as you can see the root, you know that you're querying against a specific version relative to root. Now, what is that? Sorry. So,
I'm just trying to checkpoint here and make sure that I'm following. Okay.
Yep.
The root of the tree always knows the most current version of all of the children that are running in the tree.
No.
And that's factored into the hash?
No. The root has a version of the children. The children necessarily advance ahead of the root because the root is only updated with the children as the hash ripples up through the parents. The root does not know specifically the hash of the child, but the root you can generate a proof that traces from any given root to any given child. That's what you're relying on. The children will always be ahead of the root slightly, because they have to in order for them to bubble up to the root.
Right.
But when you make a query within a chain, you are making that query relative to some root hash. And when you make the queries, you're querying the children that can be proven to be part of that root hash, which locks you so that you're not drifting and getting different answers depending on what block height your peers are at.
Right.
Now, how does that work if you want to jump across trees? I think you have to do it in one stage per tree. Like, I think you can do it, but I think it's a multi-stage process. Each tree has to execute its part of the query relative to its controlling root, and then those results get summed up.
I think we've talked about this before, the fact that like even across trees, like even in wildly different execution contexts, even when it's not actually explicitly happening, there's some kind of sense of a common root in reality between subcomponents of the system. Like it's a virtual thing at that point, like if you get far enough out.
Are you meaning simply the fact that if I'm in one tree and I look into another tree, the node at which I enter the tree has some view of what its root is, and it would convey that view to me?
More just that even if you're doing it manually, like as a person looking across like the whole cluster at whatever pieces you want, like you have your own internal stale concept of what reality is. That
reality is always stale. Reality is always stale.
And that you could theoretically represent as a hash if you were thinking like a compiler, basically.
Yeah. And it's always stale, but the point is it's reproducible. Every time you run the same command, it's going to give the same result.
Right. So can I just butt in? then just your point, are you talking about if you're on a tree and you're looking across to other trees, you're seeing kind of like a holographic projection of that tree to be able to enter it? Is that? I mean, I'm not kidding. I mean, like literally, like would there be like I don't know, like a slice there of that tree so that you would actually be able to query and jump across?
I think what I mean is that it's important to me that the model is uniform and like close enough to how human beings perceive and act that you can like think of yourself as an actor the same way as anything else on the system is an actor. Like the model that you're telling me where like whoever has authority over a cluster of chains is stale and catching up and like has some sort of way of pinning things and like talking by reference to only those pinned things is very much how a person would look at all of this stuff and make sense of it too.
Oh yeah, I mean, because in real time, blocks are being created while you're searching, right? So at some point, it has to. You have to say enough's enough and stop here, please, so I can.
We were lost on this problem for a really long time. I think this is probably why the chain host concept was always so hard to figure out, is because it's not stale. Like it's like the execution.
No, of course, it's absolutely it's a moving car, right? You can't. Which is like. I was thinking, if the thing is moving at the speed of light, right? Like that comes back to my holographic principle, where if you're looking at the object, it looks like it's not moving, but it's actually going at the speed of light. But you can see it as a stale object on your screen next to you, right?
Right.
So that's what I meant by the holographic effect. So if you're trying to look from other trees,
I understand enough about holograms. I know you did actual hologram work for the U.S. military, so you probably have a hell of a lot more understanding of how holograms work than I do. But it sounds I don't know how to say that it's wrong or right.
I'm just trying to see if there's a way to compress this query. Like if I have a light hologram version of a tree next to me or a root next to me or something like that, and it's not this very light thing that's just kind of a projection of the actual data, a data slice, if you will, and I'm able to rush into that query faster to get to the root if I need to be, then I don't have to necessarily search the entire tree for that. I just need to look at the picture of it to know where to go. I don't know.
There is sort of that concept, like we have the concept of light blocks, where a client may not need to store the full block. They just store like enough information to be able to navigate to any other block in the tree. But they don't need all the block contents. They're sort of in a way taking it on faith that the validators were correct. So there's that sort of a notion.
Right. It's like a snapshot of the validation, right?
Well, it's the validation, it's enough that you can prove you can prove any other member of the tree from the snapshot that you have, but you couldn't recompute what the validators computed because you discarded some of that information.
Right. Because I only care about the read data, right? So that's fine as long as I know that it's correct, or I have some assumptions that it's correct. The image I'm looking at is okay. I should be able to get there, right?
Yeah, I do think that's a different concept. Well, the principle here is that we have to have this notion of a root somewhere somehow, or else you can't reproduce the queries, and that's the fundamental premise of blockchain technology is reproducible calculations. And yes, we've taken that fundamental principle and just walked miles off reservation with it. But that's really to me, that's magic that blockchain brought, was being able to repeat a calculation that hadn't really been done before.
Yeah, I've had to explain a couple times now as Bitcoin and cryptocurrencies like did these massive spikes. Everybody keeps coming to me and asking me questions about blockchains, and like all the questions are wrong. The only killer feature a blockchain really has is auditability.
Yeah, which stems from repeated execution, which is a novel thing. That was a new thing.
Right.
Yeah, distributed ledger was like the killer app for Bitcoin. I mean, that's the end all be all, right? That was really what they did. So that was so cool. That was that they had this auditable, verifiable ledger that sits in the digital space.
It's that reproducibility of the equation that we're leveraging in the Dreamcatcher to do attribution, in that you can talk about attribution without wasting any chain space to actually do it, but you can recalculate what the attribution should have been, because whenever you're running any particular piece of software, you can recreate how that ran, which means that you can run a code coverage type of a formula on it to see who wrote what lines, how often did each line get hit, and therefore what are they owed. So the attribution mechanism we're using is critically bound to this reproducible execution property of the blockchains. You can't do this with traditional software with the same certainty. You can do it and you have to trust the execution environment, but in this system, you can rerun the attribution calculations for yourself from public chain usage of your software and know for sure that you are being attributed correctly. You don't need to take anyone's word for it.
So would, instead of just looking at all the leaves and children, would it just be easier if we had like a light version of the root snapshots for some of this stuff? Because that's where you really want to
mean with a light version of the root.
I don't know either. I'm just saying that if the validators did a validation, okay, so hold on. So let's say I'm the validator and I validated this particular area of the swarm, right? So I'm on this side of the web and I validated this area and I'm cool. And I took a snapshot of the roots that I validated and I said, these are sweet. And then people could query that like a Google search from that point on. Like, okay, this is the route I need to go to, or this is the route I need to go to. So you'd have these addresses in this space, this web space, that it was like pointing you to the correct routes that you need to go to. So since the validators have already queried them already for you, so why double up the work if that information is already available? That's all I'm thinking. So that you'd have this like light snapshot that's cut through the web, and you would actually know where you need to go in like a map. You know, like the GPS coordinates are already there.
I don't know how that would work exactly and still maintain the provability or the repeatability aspect, but perhaps what you're getting at is that there is, early on we identified that there was a need to break out of chainland in like a distributed hash table. So for example, discovery of other chains, that can't really be done on chain. That has to be in a different kind of structure. The one that we settled on was a distributed hash table, just like trackerless torrents, where if you want to find a chain, you can sort of do these searches and then people will give you hints and then you can verify that you've got the right thing. So maybe you're only trading very light pieces of information about these chains and about these routes. And in relation to torrents, you're sort of relating the root of an application is the same as a torrent file, and then within it has all these hashes of all the files that it has below it. So if you want to find a root, or if you want to find a particular chain, you need to know its root, and then from its root you can use the DHT to find where to go to get it, and then walk back down to get that particular thing, something like that.
Yep. Well, yeah, to use your analogy, though, that in that case, the validator would be the site where you got the torrent. And if you trust that site or not, right? And we're all good, we're all happy, we all use the same site. And that site's searchable, right? I can do a query in that site to tell me where the torrent starts, or where the torrent is, or where the file is. And I can do a checksum on it and all that stuff, right?
What you're saying isn't wrong. I don't feel like I understand or see how that would work in this system. Perhaps as we progress, we might be able to fulfill that metaphor.
Okay. Right.
So can I talk for a few minutes about why I keep asking the question about crossing trees?
Sure.
I think once you start to build up like a decent sized application, the question is going to come up over and over again of like, what are the bounds of pieces of this application? So the way I think of a root, as we've talked about them in the past, the way that I think still checks out for me based on our conversations is that a root defines like a code boundary of some sort.
The root defines a consistency boundary.
Right. I guess I always think in terms of code. I always think in terms of building applications. A root can be there for data as well, right? And that's like a file tree, right?
Yeah, the root guarantees that the children below it follow the rules that the root set.
Right.
And that affects data as well as computation as well as the composition of the tree.
Right.
It's basically saying that everything from this point down is paid for ultimately by this root, but it's also controlled by this root. And the root contains within it meta information about the tree, like what are the covenants that are being run in each of the apps, what version is the software up to, who can have access ultimately to kill the chain or kill the app, kill the root. Those types of things.
So even outside of Chainland and in the normal kind of practice of building applications right now, there's a confusing question of like, do I make a library or do I make a SaaS product? There's a lot more developer-facing libraries that are bundled and built as their own political organizations that present their functionality behind like a network API, right? And like that behavior, that functionality might be something that once upon a time would have been included in an application as a library. So when I'm building something, I always have these choices of like, am I going to add it to the core of the thing I'm building? Am I going to pull in some library that somebody else wrote? Or am I going to go off and interact with some other political entity that's presenting it as like a SaaS product? And they all come with trade-offs. I think every application is probably going to eventually hit a point where it wants to talk with other applications because the people that are in charge of the code and the system and the structure in that other tree don't want to be like politically bound up with the other organization. And I understand that the attribution like is the same either way, whether or not like this foreign library entity is like trying to keep a bubble around the things that it's doing, or whether they're trying to present themselves as like code that just gets factored directly into the code that I'm writing. Like, do I have a fundamental misunderstanding here? Because you're wrinkling your forehead a lot.
I think I was just born like that. I don't understand the question, though. Like, what you said, nothing's wrong with that.
Right.
I don't get the question.
What I'm saying is, like, this model sounds nice to me when you're building something and you like everyone's friends and you're allowed to pull their stuff into your application.
But don't forget, like we're simply talking about the Dreamcatcher model is the limiting form of what the attribution and voting mechanisms that we talk about can be. It's a maximum of how things can be done. We support, or we aim to support, any other means of political organization for the production of software and other goods. We're just simply saying that if you had a data structure such as ours and a chain such as ours, you open up the possibility to have a new form of governance and attribution whereby you can sort of define it as an algorithm as opposed to an assertion. But we necessarily, within our modeling language, support all these other forms because we want to model the whole world around us and interact with it, hopefully to basically absorb it, undercut it, and basically make it worthless. But still, in the meantime, we need to interact and model these things.
Understood.
But that doesn't.
Are you asking whether or not you can actually wall off your section of the bush, if you will, your web area, or is that? I'm
saying that inevitably people will.
Oh yeah, absolutely. Well, we know that. I mean, we're opening the floodgates to the maximum value, right? And then if you want to go min side, then that's on you, right?
Yeah, right. Like, and what we want is we actually want people to choose that min side so that we can actually present them as a case study. Hopefully, our version shows that actually it's maximum to do it this way, and this is what minimum looks like, you know. But we need some data and we need some actual use cases, so we do actually want some people to do that.
So, I mean, so we could show a deck and say, hey, look, these guys are men over there and they're only making $10,000 a month. These guys are doing similar stuff and they're maxed out and they're making hundreds of thousands of dollars a week.
Right. Exactly. That's exactly what we want. Yeah. These guys are closed source. This is this other model. The closed source guys are having this type of lifestyle. We're having this one.
Right. So tying it all together here, it really seems like the two views on anything that's going on inside of a cluster of chains. One is like you're looking at it from the outside. You're always doing it by reference to a hash that rolls up all the information in some tree of things that are cooperating together. That hash is like the information lost version of the thing that you're kind of using as a reference point. Versus everything is open to everything else, and like they're all in the same tree, and they can maximize their value because of it.
I'm still not clear on the question, but I think I can spot something I can answer. If that makes sense.
I can give an example too, if necessary.
So when if an organization keeps the majority of its tree hidden, it will still want to interact with the rest of the world, so it will expose one of its chains. That chain may or may not be at liberty to disclose the state of its hash or its root hash, the thing that controls it up the tree. Because cyclically, the children always include the root hash the next time they do something. So the child includes the root hash the next time it does something. In the act of doing something, it necessarily made the root's view stale, but it carried with it the last known view that it had of the root. And so anything that it communicates with, even though it doesn't carry that exact hash, it does bundle that hash up into all of its communications with the other chains. And so if it were to supply you with enough information, you could generate a proof that walked back from your last view of it to its root and then down to some other part of the tree. So in a very sloppy way, I'm trying to explain that we want to see a system where you can express the whole world's information as one hash, but that doesn't mean that there's only one such hash. There can be as many hashes that can say they represent that property as there are people on Earth. It's representing all the world's data as one hash doesn't mean it's the only hash that represents all the world's data. It just depends on where you're looking from.
Right. Which, I mean, the only thing that would realistically change then is the staleness of pieces.
Yeah.
Yeah, because we're talking about relativistic hashing now.
Relative.
Yep.
And the order of your connections, as well as the staleness of your connections, would determine the different sort of qualities of the hash that you think represents the world.
Right. Because that would be your perspective of the tree or bush that you're in.
Yeah, exactly. That's your perspective on the universal tree of knowledge. And
that's right. Well, that's what I'm saying. It's a relativistic hash, right? Because it's relative to you.
Yeah.
Well, the example I was going to give was the fact that we had this conversation earlier. I don't know if you remember, Tom, but we were talking about how somebody who posted something, a library, for instance, on the blockchain, and everybody started using that library because it was just such a great tool.
Yep.
And then they tried to make that library closed source, and how that wouldn't work. In this particular example, that would just be fraught with danger. Like they wouldn't be able to do it.
In the blockchain world, that model it's so hard. Like blockchains are such a fucking difficult thing because they have to be open source for anyone to trust them. And then the apps that run on top of them, you can't then be like, and this is our closed source smart contract. Put your money here. Like, it's almost like we need an open source business model that's standard and fair and everyone agrees with, because we are forced to be open source. It's just how the blockchains seem to have gone.
Is there any way to build something closed source on top of an open source foundation?
Absolutely. Oh, absolutely.
Yeah,
absolutely. It's just that I would like to. I believe that the fundamental gamble we're taking is that I believe there is a business model out there that allows you to be completely open, not open core with some closed proprietary bits, not like dual licensed, not anything like that. Like, I think there is a genuine open source, fully open source business model where your operations are fully open as well. So you're open state as well as open source. Your open participation, so anyone can come in and go, and you're basically trying to approach a permissionless company that is fair and predictable in how it rewards its participants, so that you can ultimately one day vacate the throne, have no one technically in control, and yet this thing just produces good value.
And I fully expect this thing to be on an NSA server somewhere, air-gapped, and it would still function, right? I mean, that's about as close source as it gets.
Yeah.
But it's doing whatever it's doing for them. And as long as they don't ever plug the cable in and it talks to the validators, they don't care.
Yeah. But I mean, like just talking about the NSA, I mean, this type of model of this type of computing platform where you have this reproducibility is sort of like, I mean, you'd almost want, if you were the NSA, you're like, so we've got all these servers. You guys want to run all this data. Why don't we be one of the validator sets? And if you're running your chain on us, we can look inside it. Trust us, we're the government. Also, it's very cheap. And we'll also guarantee that it's secure. Like, it would be great if the NSA made a business proposition instead of just we'll just take it, thank you. Like, they could provide a service back to the people, which is like secure operations, because that's what the people want anyway. And the side effect is they get to see everything you've got. Fine, make sure we don't get invaded.
Yeah.
I mean,
still not feeling like I got your question though, Ben.
All right, it's okay. I'm like, this is just strictly coming from the perspective of somebody who's trying to build an application. Like, and I think it's probably just underbaked. It's not even a question. The reason why it doesn't seem like a question is because it's not a question.
I mean, in my mind, your question is more of like, if I'm using open source libraries and it becomes closed source one day, how does it affect my app? I mean, that's a big problem, right? But I think it's impossible to do that on this chain, because once you set something to open, you don't really unclose it. You can't really unopen it anymore.
You can
it's
close,
open.
You can close the next versions. Like, you can start closing.
Right. You could fork and do whatever you want, but that version 1 that's on public chain, that public library, it's going to stay there.
Once open, stays open.
Right. And if you want to make a change and make it and monetize it and close it, then you have to do version 2. That's a fork.
Yeah.
Right.
It's bothering me that I don't get what you asked, Ben.
It's okay. It's because I'm like,
he's fomenting a question.
I'm in two places in my head right now. Like, I'm not as present as I should be. I'm still left with the question when I'm building something of whether I should build it myself or look for somebody else's solution.
Oh, and I mean, but isn't that part of reputation though, right? Like, if you're, the first thing I always do when I design a product is I always first look to see, I do market surveillance to make sure that somebody else hasn't already invented that wheel, right? And then if they've done a pretty damn good job, either A, I'll copy it, or B, I'll improve it, right? And And in your app world, if they've already done all the groundwork and the code's great, then I would just use it as a library, right? Is that what you mean?
I know. It's like, it's more like, I know developers and I know that they always want to reinvent everything all the time. And I think that the biggest challenge here is figuring out, the biggest challenge here, like honestly, if you're trying to bring developers onto this platform, is going to be figuring out how to convince them to care about political things in order to incorporate a library in their application, or like some kind of outside service that they have less influence over. Like I know it's better for everybody if they organize that way, right?
I think you mean like if I have a serious problem with a QAnon cult area of this web, but they have some great source code that I need. Am I going to use that code? Is that kind of where you're going?
I don't think that's what he meant.
Okay.
I think what you meant was that when you're embarking on a project of your own, you're going to do this project anyway, but there are parts of it that could be reusable elsewhere, and you come to a decision point of, should I make a new library or should I use someone else's library? And if I'm going to use someone else's library, how do I find what I want, and how do I make sure it does what I need? Was that more like what you're asking?
Here, let me just go way out on a limb.
Okay.
No pun intended.
Yeah. I believe that every single function should only ever be written once. If it is written, it should be consumed.
I
believe that.
That's conflicting. Anyway,
right. I believe that. I'm not trying to convince any of you. I think that the maximum utility system is the one where, everybody who's writing programs is no longer wasting their time redoing the same thing over and over again.
Okay, well, let me try and explain to you a couple of the mechanisms that we hope start to show dominance within the Dreamcatcher that have a tendency to go towards the utopian state that you're talking about.
Okay.
Right? If you release your project in, let's just deal with Dreamcatcher native for now, ignore any other business models that people might have. If it's Dreamcatcher native, it's open source, you can fork it, modify it, whatever. You make a project, it's got some library in it. Someone else sees that actually that library is a duplicate of this other library, but you can't migrate to that other library because your interface is X. Right, but you need it to be X plus 1 or something. And so there would be an attributional incentive for an independent person to make a pull request against you that modifies your code to use that library. That person would receive some attribution for that change. You would maybe get, a better performing library in there. Those types of things, they're because you can make money by improving these, or deduplication can make you money in this system. And so some people will go out and do it when they spot it.
But wouldn't, if I copied it and included it in mine, wouldn't I be losing part of my cut if somebody else added their attribution? It's basically am I doing things by value or by reference, basically?
So you're saying by value would mean that you don't want to part with your cut to this other library, you want to keep it yourself?
I think it's a perverse incentive that I can't work my head around, basically, right? For me
to... I could say I wanted to use LeftPad, but I was like, fuck that guy. I'm going to just copy his code and put it into my code and not pay him any attribution. Is that what you mean?
Exactly.
Okay, good. So if you do that, then you have copied code. and we can detect that, and we can pass on the attribution anyway. Like, here's a fundamental design principle of the Dreamcatcher that is very subtle and not really needed, but is crucial to have for the sake of crucial to have once operation gets big. Okay, and that is the ability for any single person who's paying to alter how the attribution gets dispersed all down the tree. Now, why is that important? In an extreme case, let's say I buy this t-shirt and I can trace its provenance all the way through where it came from, who worked on it, how long it took, all that. And then somewhere in the forests of Vietnam, there's some child labor being used to make this shirt.
Mm-hmm.
When I buy it, I should be able to say that attribution there should be different to how it's currently flowing right now.
Okay.
Right? So if I consume your library, and you've got plagiarized code in there, I should be able to set the attribution that's going to happen from me to you, and then which slice is going to go off to left pad, even though it's not officially linked in the package JSON. It's linked because our mining algorithms, our sort of plagiarism search algorithms have detected that, yeah, it actually some attributions due over here. Right. And so anytime you make a payment, the point and why I'm like, we don't need a governance token in the Dreamcatcher. It's this model that we want to use that says that every transaction, you can cast a vote with that transaction that votes on a change of state somewhere, arbitrarily anywhere. And so when I pay you, I'm going to vote that my payment to you is actually split between you and the left pad guy, even though you don't officially declare it.
Yeah, I think the broad strokes answer to your question is, or to my question is, consumption is political.
Every single consumption action is a political action. And we are making that directly coupled to the political state of the entire world arbitrarily, depending on who wants to do it. At the moment, it is so blunted and so distant from being a political action that everyone's in apathy. They're like, fuck it, I'll just buy the child labor t-shirt. Fuck it. Right? But
and I'll get child labor written on it.
Yeah, just to prove a point, right? But because we have this ability to do not just microtransactions, but like dust level transactions, they still contain information. Every single consumptive action is a political action in this system. You can choose not to use that political action, or you can actually do something with it. The point is the feature is there to be used. It's not there in any other systems. That's the key feature in the Dreamcatcher for consumers.
Yeah, I mean, I never thought of it that way. I mean, I guess that's...
You literally vote with your wallet.
Yeah.
Right. I mean, you do. You do in real life. It's just you don't really have that many.
Yeah, but you don't think about it that way. No one goes to the store and goes, "God damn it, Nestle! You know I hate you, but I'm still going to buy your shit anyways." You know, I mean, I do that, but not a lot of people know what a shitty corporation Nestle is, right? You have to go and look it up, and no one has time for all that.
Exactly. And yet, in this system, because of this incentive to actually model the world, people start to model out Nestle in a way that they can use to vote with their transactions, and each person adds a little more to the model and improves it a bit. But the point is, if Troy goes and does his research, he'll have a very difficult time sharing it with me in a way that I can actually do something meaningful with it. But if it's taking place in this model, and that's sort of like, I'd really love to have a good solid rant about the metaverse one day. But the point is that with blockchains, particularly with these tiny blockchains that we're making, we open up the ability to make an object model of the world and deduplicate it and connect it to everyone who wants to share that model, which allows it to gather amplification at an extraordinary rate if we do this right. And so every person can nudge on something a little bit, and that little nudge can be reused by the next 1,000 people. That looks like growth. It starts to become more and more useful, so more and more people use it, blah, 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 and all that. But we're trying to make object-oriented software that's deduplicated, shared by arbitrarily many people, and connected to everyone of relevance.
Right.
I mean, every computer program makes within it an object model of the world. The travesty is that those object models are isolated, separated, not connected, not shared, incompatible. There's no incentive to make them fit with another program, right? Whereas here, we're making the objects able to exist in isolation on their own, and then the apps actually compose them together, as opposed to the app making them, owning them, and not sharing them. It's actually more economical to share them and keep them up to date, and to make an app that pulls them in rather than one that tries to own them completely.
Right. Of course, when you say it that way, like the scarcity thing that blockchains can do should be applied to like the actual business outcome of everything that's happening
of
on
everything,
right? Like,
of everything.
people shouldn't.
The opportunity
People shouldn't.
ahead of, sorry.
People shouldn't ever be doing the same thing in parallel to each other without knowing about each other.
Right, that's like, it's like, I mean, like cavemen did that. A caveman in a cave down the road did the same shit that the other caveman was doing. They never knew about it, right? Like, how is that different now? It's like, we have computers. That shouldn't be happening, right? No one should be duplicating their effort, and yet it seems to be worse now than it ever was before.
For sure. Yeah, I think that's because most tech gets used as like a way of hiding shit right now, not exposing it.
Yeah. And
yeah, well, we want to make it an economic incentive to share and be open as much as possible.
And the base incentive that we're working on is a physics energy type of one, which is to say that if it costs energy to maintain a chain, host a chain, keep it up to date, then it's less energy to share it with others who also have an interest in that object. So, you know, like, it should be happening.
Do you think it actually reflects? But like, if you have a validator network, does it actually cost less physical energy on average if that network is bigger?
Well, given the way that the design that we have for the mainnet, and given that you can specify how many validators you want, either like, 4 or 400 or whatever, then you can definitely have it very energy efficient and be something that's reusable.
Right.
But yeah, every single consumptive action is a political action, and we have the opportunity ahead of us to design a system that allows that to be explicit and arbitrarily granular so that any transaction, no matter how small, can have a political pull on any state of anything in the world, or the whole. Like, there's no limit. There's no limit to how small the thing can be, and there's no limit to how many things can be included in its vote, as it were. That is the system that we want.
I think there's actually going to be some kind of coordinated consumption effort, actually.
Well, yeah, like, how can there be when we're so disconnected, right? But we got to start making something that actually gives us the tools to make it coordinated.
Well, the coordinated efforts are the DAOs that are going to be popping up inside the system.
Yeah. Yep.
Because you'll be what you are. You will be a member of all these little tiny DAOs. You'll have the DAO that your hobby is. You want to play guitar. You'll have the DAO that you want to explore blockchain technology. All these like little tiny communities are going to exist autonomously on this chain. And, you know, it's just a matter of you wanting to go there and participate or not. You know.
Right. I gotta hop off, guys.
Sweet.
All right.
But before I go, I mean, like, what should we queue something else up to talk about next time? Is there any more places where you want me to like dig and look? Should I just keep going with reading through the stuff in the Google Docs, or?
The thing that's
I mean, I would like to have a meeting before the investment call. That's for sure. I don't know if that's applicable to this next Saturday or earlier, but I'd like to have that with everybody.
Yeah, I want to have that too, but I do need a bit of time to think. I'm unavailable for the coming week.
Okay.
Yeah. Anyway, I'll stop the stream and then